This is for period 3, showing you the last two problems on the final exam review. First one says a chain fits tightly around two gears as shown. Distance between the centers of the gears is 27 inches. The radius of the larger gear is 20 inches. Find the radius of the smaller gear to the nearest 10. So here's the larger gear, here's the smaller gear, and the sketch looked like this. And we have this tangent, and because it's a tangent, we know that it is perpendicular to both radii at the point of tangency. And in the sketch, I told you that this distance was 20 inches. Now, we're also told that the radius of the larger gear is also 20. So this here is also 20 inches. And we're also told that the distance between the centers of the gears, which would be this line segment right here, that is 27 inches. So what you want to do is you want to draw a line from this center here to this line segment here. Let me draw it for you. Something like that. And you want it to be parallel to the tangent. And if it's parallel to the tangent, then what you're going to get are parallel lines, and you will get a rectangle with 4 right angles. And all opposite sides of the rectangle are congruent. So if this is 20 inches, then this here will be 20 inches. And then what we'll have here is a right triangle where this is the right angle, and 27 inches is our hypotenuse, and this 20 inches here is our leg. This is a leg. And all we need to do is to find the length of this leg. And we can do that very easily using the Pythagorean Theorem. So it will be x squared, that will be the length that we're looking for, plus the length of the 20-inch leg squared will equal the length of the hypotenuse, 27 squared. So x squared plus 400 will be equal to 729. And then x squared will be equal to 729 minus 400, which is 329. And then if we take the square root of that, we will get an approximate value of x to be 18.1. And if x is 18.1, that's this piece right here. And if the whole thing is 20, then we take 20 and we subtract 18.1. And what we get is 1.9. So that means that this piece right here is 1.9. This right here is 1.9 inches. And because it is a side of a rectangle, and that means this is 1.9 inches. So the answer to the question, the radius of the smaller gear, is about 1.9 inches. And that's your answer. Okay, the other problem that I showed you, or that I put on the board and I didn't get to, was the one involving the perimeter of a polygon. I said, find the perimeter of the polygon that circumscribes the circle. And the sketch that I had drawn was a circle, and I had something like this, and this, and then I had, I believe I had this, and this. And let me clean that up a little bit. So you can see that this circle is circumscribed, or the circle is inscribed within this triangle. And then I gave you some lengths. I said this was 8 centimeters. This was 16 centimeters. This was 9 centimeters, I believe I said over here. And I said that this was 6 centimeters. Well, the key to answering this question is that you have to understand that tangents from the same exterior point to the same circle are congruent. So that means this is 16 centimeters. Okay, this is 9 centimeters. This is 6 centimeters. And this is 8 centimeters. So I think we now have all the side lengths to our polygon. So it's just a matter of 16 times 2 plus 9 times 2 plus 6 times 2 plus 8 times 2. And that will be our perimeter. So we get 32 plus 18 plus 12 plus 16. And what we're going to get is, let's not guess at this, let's use our calculator. So it's going to be 32 plus 18 plus 12 plus 16, and that is 78. So our perimeter is going to be 78 centimeters. Okay, so those are the last two problems that we had on the review that I wasn't able to get to, so hopefully this helps. And if it doesn't, come see me and I'll try to give you a better explanation.